Okay, example 30. The depths before and after a hydraulic jump are 1.2 meters and 1.8 meters in a 2-meter wide channel. Determine the flow rate, the fraud numbers before and after the jump, the head loss in the jump. So Q square over G equals depth 1, depth 2 over 2, quantity depth 1 plus depth 2. That's the formula for small q, or discharge formula for rectangular sections that undergoes a hydraulic jump. So substitute, everything is given, the depth specially. So small q square over 9.81 equals 1.2 times 1.8 over 2, quantity 1.2 plus 1.8. So we can compute q. It is equal to 5.638 cubic meter per second per meter width of channel. So the discharge therefore, which is q times b, and b is 2 meters. So times 2, the discharge is 11.28 cubic meters per second. Fraud numbers before and after the jump. So formula for FR, fraud number is velocity over square root of GD for rectangular sections. So V1 is Q over small q over depth 1. So 5.68 over 1.2, 4.698 meters per second. Mean velocity at section 2 after the jump is 5.638 over depth to 1.8. So it is 3.132 meters per second. So FR1 is equal to velocity 4.698 over 9.81 times 1.2. So FR1 is 1.369. It is expected greater than 1 because before the jump, the flow is supercritical supposedly. And after the jump, it is below 1, subcritical. So FR2 is equal to 3.132 over square root 9.81 times 1.8. So FR2 is 0.7453. Another way of computing FR2 is using the direct formula 2 square root of 2 FR1 whole over quantity square root of 1 plus 8 FR1 square minus 1, then close raised to 3 halves, if you can remember. So 2 square root of 2 square root of 2 FR1, then quantity square root of 1 plus 8 FR1 square minus 1. So this is close supposedly, or you may remove this parenthesis, raised to 3 halves. I want you to compute for that. Or FR1 is 2 square root of 2, FR1 is 2 square root of 2 FR2, which is 0.7453 over square root of 1 plus 8.7453 square minus 1 raised to 3 halves. Verify that it is also 1.369. So I will leave that formula for you so that you can familiar with that direct formula. Then let's proceed to the head loss. Head loss, the shortcut formula is depth quantity depth 2 minus depth 1 cube over 4 d1 d2. Although we can compute head loss as specific energy at 1 minus specific energy at 2, the easier way to recall. But we already used this in the preceding examples in problem 29. So quantity 1.8 minus 1.2 cube over 4 times 1.2, 1.8. So the head loss in the jump is 0.025. So another way, if you cannot recall that, is specific energy at 1 minus specific energy at 2. Anyway, we already computed the velocities. So head loss in the jump is quantity 4.698 square over 19.62 plus 1.2 minus quantity 3.132 square over 19.62 plus 1.8, depth 2. So the head loss in that jump will also give us 4.025 meter.